Now we are on to periodic table trends, and we're going to practice going through the trends. There's 10 different examples on your Google form that you guys will complete after this. I will make sure to give you the diagram. So, for example, if I ask a question about electronegativity, I will give you this diagram that shows the trend and the elements and everything like that. Also, if I do specify certain elements, I will make sure to state the symbols since the symbols are easier to read off of this table than the names. So let's just start off by generalizing which element has the greatest electronegativity. So we can see that electronegativity increases going to the right and up. However, noble gases are not included in the electronegativity trend. So that means excluding that far right column, which element is farthest to the right and up. So that would be fluorine, farthest element to the right and up. So it has the greatest electronegativity of all the elements on the periodic table. But now let's look at specifically some specific elements. So we are looking at barium, strontium, calcium, and magnesium. Which one has the greatest electronegativity? So let's first find them on the periodic table. So barium, strontium, calcium, and magnesium are all right here. Okay, so all of these elements are in group 2. So that means that we can just focus on this trend up here where it increases going up. So whichever element is closest to the top of the periodic table has the greatest electronegativity. So let's look. We have barium at the bottom, strontium, calcium, and then magnesium. So magnesium of those 4 would have the greatest electronegativity. Now we are on to ionization energy. Ionization energy follows the same pattern, increasing to the right and up, but it does include noble gases. Ionization energy is the energy required to remove an electron, and the noble gases really don't want to have an electron removed, so it takes a lot of energy to remove one, but you can do it, so they are included in this trend. So which element is farthest to the right and to the top of the periodic table? Well, that would be helium. So helium would then have the greatest ionization energy. Now let's look at some specific elements. We have strontium, yttrium, zirconium, and niobium. Which one of those has the greatest ionization energy? So let's find them on the periodic table here. So we have yttrium right here, zirconium, niobium, and strontium's right there. So they're all in a row. So that means all these elements are in period 5. I know they're in period 5 because you just count down 1, 2, 3, 4, 5. So they're in period 5. And we're going to look at this trend over here at the top that says increasing going to the right. So whichever one of these 4 is farthest to the right has the greatest ionization energy. So strontium is farthest to the left, then yttrium, zirconium, and niobium is the one farthest to the right, so it has the greatest ionization energy. Next is electron affinity. So electron affinity is the other one that does not include noble gases. Noble gases do not want more electrons. They are not interested whatsoever, so they are not included in this trend. But which element, just in general, has the greatest electron affinity? So this is going to follow just what we looked at for electronegativity, going whichever element is farthest to the right and to the top, except for the noble gases, and that would be fluorine with the greatest electron affinity. Now let's look at some specific elements. So we're looking at phosphorus, sulfur, arsenic, and selenium. Let's find them. So here we have phosphorus, sulfur, arsenic, and selenium. So these aren't in just one row or one column. These form a square. So we're going to need to think through this a little bit more. But since these form a square and we know that electron affinity increases going to the right and to the top, whichever element is in the upper right corner has then the greatest electron affinity. And if we look at our square, which is right here, Sulfur is the one that is in the upper right corner, so it has the greatest electron affinity. Now we're looking at atomic radius, and atomic radius switches. It increases going to the left and down. So we don't really have to worry about noble gases, but it's just good to note noble gases are included in the atomic radius. So if I did say, hey, which of the noble gases has the greatest atomic radius? That's a valid question. But for this, we're just looking at the left side of the periodic table. So we're looking to the left and the bottom, which would mean francium, farthest element to the left and down, so it has the greatest atomic radius. Now let's look at some specific elements. We have polonium, tellurium, selenium, and sulfur. So these are right here. So they're in wall 1 column. So this is group 16. And the trend states that it increases going down. So whichever element is closest to the bottom of the group has the greatest atomic radius. So that would be polonium. So polonium has the greatest atomic radius. Next is metallic character. This follows the same trend, and just as with atomic radius, noble gases are included in this trend. Noble gases aren't obviously metals, but they do have some characteristics of metals, which ones are more metallic than others and everything like that. But we are going to be looking to the left side of the periodic table because we want to find the element with the greatest metallic character of the periodic table. And just like this followed the same thing for atomic radius, it's going to be the same element. Francium is the farthest element to the left and down, so it has the greatest metallic character. Last example, we're going to look at scandium, titanium, yttrium, and zirconium. Where are they? Here we go. Scandium, yttrium, zirconium, and titanium. Which one of them has the greatest metallic character? So again, this is not just one column or one group. So we're going to have to use both components of the trend, increasing to the left and increasing down. That means that we're going to be looking for whichever element for that little square, for this square right here, is in the bottom left corner. So that would be yttrium right here. So yttrium has the greatest metallic character. Okay, so that's it for this video. Go ahead, take some time to work on the periodic table trends form. If you have any questions, please let me know. Again, you will be given these big diagrams that have the trends. I would make sure, though, to write down which ones include noble gases and which ones don't, because you are going to need to remember that. Okay? If you have any questions, let me know.